All right, what's going on, guys? So we're gonna go over the assignment that I posted on Wednesday. What I'm gonna start doing, because I'm noticing that a couple people don't have the textbook, I'm gonna start taking pictures of um, the questions and actually putting them on Google Classroom. So if you didn't do it yet, don't worry about it. Just make sure you're paying attention, especially since you kind of need to have it in front of you. Since we're gonna be going over the actual graphs, so. Um, what I assigned you guys for the 20 questions, it was basically on the atmosphere and the relationships between the dew point and the relative humidity. Okay. So for the first part, it gives you a graph and says the greatest change in air temperature occurs during the period from. So what you have to do is for the greatest difference, you have to find basically the difference between the relative humidity and regular temperature. Okay. So if you do that, you'll actually notice that the dark line, which is the temperature, and then the dashed line, okay, the line that goes like this, that's the relative humidity. You're trying to find where they're different. So when you have the relative humidity, the regular temperature, okay, and then you have your relative humidity, you're trying to find where they are separate, all right, as much as possible when they're farther away. So you're going to find places like this. So when you actually go down and you look at what time it is, you get 6 a.m. to noon. So number one is going to be choice 2. Okay? Because you're trying to find that difference. Now, for number 2, which conclusion concerns the relationship between the dew point and the temperature is best justified by this graph shown? So you'll notice that there's another line where instead of dashes, they just have little dots going. And you get the dew point kind of something like this in that graph. So the only case or choice that makes sense for this one is the change in dew point does not necessarily occur when air temperature changes, okay? So changes does not happen. The dew point kind of stays by itself. It doesn't get affected by the air temperature going up and down, okay? What's going on, Christian? This is actually 8th period. I already got the 7th period on YouTube, okay? It's under the same date, but it says general science. All right, so dew point does not get affected by this graph when relative humidity or regular temperature goes up and down. Number 3, the graph indicates that as the air temperature increases, the relative humidity. So as air temperature goes up, what happens to relative humidity? It goes down. So number 3 is also going to be 2. And then the same thing, when air temperature goes down, relative humidity goes up. Number 4, condensation most likely occurs at approximately. So this one's a little bit different. So with the relative humidity, okay, and condensation, and also the dew point, all right, we're looking for when. So I'm going to get rid of this. For condensation to occur, all right, you need regular temperature and the dew point to be the same. Okay, so you're going to find where the dew point and the regular temperature hits each other, and you'll notice that it comes around 6 a.m. So number 4 is going to be choice 2. Yeah, you can still watch. Number 5, the greatest difference between the wet bulb and the dry bulb temperature on a sling psychrometer would occur at approximately. So all you have to do is we got to find the difference, and it would be 3 p.m. So number 5 is 4. Number 6, which combination of air temperature and dew point temperature would most likely occur in humid air. So remember, we're trying to find where the dew point and the air temperature are both relatively high, okay? The numbers look small, but remember, they're in Celsius. They're not in Fahrenheit, where we're used to. So the only choice where both of them are great or higher than all the other ones is going to be choice 3, okay? The dry bulb temperature is 20 degrees Celsius. The wet bulb temperature is 17 degrees Celsius. What is the dew point? All right, so remember this. There are 2 things we got to use for this. The first thing, we got to do some subtraction. The other is we got to use the reference table, okay? So make sure you have your reference table out in front of you, and you go to page 12, okay? And since they're asking about dew point, we're going to be using the top graph. So we have the dry bulb temperature, okay, which is 20 degrees Celsius, okay? And then we get the wet bulb, which equals to 17 degrees Celsius. So before we can even use this graph on here, we got to find the difference. So we do 20 minus 17, we get 3 degrees Celsius, okay? That is the difference. Now, remember this graph, you have the difference at the top and you have the dry bulb temperature on the side. So we have to go down where it goes to 20 degrees Celsius, and then we find the difference, 3 up here, and all we do is we follow it across, and it gives us a number, okay? And that number for number 7 is going to be 15 degrees Celsius. And why do I say Celsius, since we're always used to Fahrenheit? Because that's what the chart is in. It's always in Celsius, okay? So for number 7, it's going to be 1. All right, so now I'm going to get rid of all this. So in your book, again, on page 318, we have another graph, okay? It's a little different. Kind of looks something like this. So we got a line going around like this. And then we have another one. Goes like that, okay? So when was the air temperature at ground level saturated with water vapor? So you're going to look where air temperature and dew point connect, and it comes to being over here. So when you follow that down, it's going to be 6 a.m., okay? Because that's when they meet, is for the air temperature. Yes, you guys are both right. It's school's closed for the rest of the year, okay? But we're just going to do the best that we can for now and learn about some weather. All right, so 6 a.m. Tuesday. So number 8 is going to be 4. All right, number 9. The air's capacity to hold water vapor was greatest at. So now, remember, when we're talking about air temperature, the warmer it is, the greater it can hold air temperature or water, okay? So when we're looking at this, we have our dashed lines. This is the highest it can be. So this is where it's holding the most water. So if you follow that down, you get 3 p.m. And 3 p.m. comes out to number 2, choice 2. All right, number 10. If this trend should continue, the air temperature at 7 p.m. Tuesday was probably about, so it kind of got cut off, but you'll notice that the temperature starts going down. So if you predict where it's going to be, the only choice that makes sense is going to be 8 degrees Celsius, which is also choice 2. How are we doing so far? Any questions? All right. So number 11. Actually, since I've already wrote this down, you can always pause it and go back. Start 11. Okay. So the relative humidity was lowest at. So again, relative humidity. We're trying to find where it's separated the most, okay? You'll notice when the difference between the dew point, okay, and the regular temperature, the further apart it is, the less relative humidity when you're looking at your chart, okay? Especially right here. As you get to the difference and you look at 15, the relative humidity is really small. When there's no difference, it's always 100%. So you have to find where the regular temperature and the dew point are furthest apart. And when you do that for number 11, you're going to get 3 p.m., okay? That was when they were both separated the most. So number 11 is going to be choice 2. Number 12, the air temperature. Classroom has a dry bulb temperature of 10 degrees Celsius and a wet bulb temperature of 4 degrees Celsius. So now we're asking for the relative humidity. So it's like the other question, but instead of using the dew point, we're going to be using relative humidity now. So we got to find the difference. So they give us 10 degrees Celsius for the dry, and then the wet bulb is 4 degrees Celsius. So we find the difference is 6 degrees Celsius, okay? So we go to our chart, we find the dry bulb temperature, which is 10 degrees. We find the difference, which is 6 degrees, and we follow it down. Since we're using the second chart for relative humidity, it's not going to be in degrees Celsius, it's going to be in percent. And when you do that, for number 12, you get 33%, which is choice 2. Okay? All right, number 13, according to the Earth Science Reference Table, an air temperature of 15 degrees is equal to, so this one's a little bit different. We got to go to page 13. We go to our temperature chart, and we just have to convert it carefully. So we're going from 15 degrees Celsius, and we're going across to Fahrenheit, and you get 59 degrees Fahrenheit, which is choice 4. Okay, that type of question comes right through it, all right? Number 14. If the air temperature were 20 degrees, which dew point temperature would indicate the greatest water vapor content? All right. So let's get rid of this. So we have 20 degrees Celsius. Okay. We're trying to find the greatest water vapor content. So it's going to be as close as possible to 20 degrees Celsius. So the only choice that's close enough is 18 degrees Celsius. So number 14 is going to be 3. And remember, if we were to put this whole problem in, the difference is 2. And if we go, because remember, we want to be finding how much water vapor. If we actually solve this for relative humidity, if we go to 20, and then if I go to 2, it comes out to be an 82% humidity. Okay, so that's a lot. Now let's say instead it was 20 degrees Celsius, and I said the dew point was also 20 degrees Celsius. There'd be no difference. You look at the relative humidity chart, it's going to be 100%. So that's going to be a really humid day, okay? It's not going to be nice to be outside. Okay, 15. As the difference between the dew point and air temperature increases, the likelihood of precipitation. So what I just talked about, okay? If the temperature, let's say it's 50 degrees Celsius, okay? And we get 40 degrees for the dew point. The difference would be 10, okay? If you follow that along, it's going to be a very low relative humidity, okay? And I'm thinking about Fahrenheit, so let me change this up. If I do 30 degrees Celsius, all right, and I do 20 degrees Celsius, difference is 10, okay? I go to 30, which is a really hot day, and I go to the difference of 10, it's going to be 39% relative humidity, okay? Yeah, this is 8th grade. Now, if you change it, if you got 30 degrees Celsius, and now let's go to 25 degrees Celsius. Difference is now 5. We look at the same thing. We go to 5, and now it's 66 degrees Celsius. So the closer the dew point and the dry bulb get to each other, or the dry bulb and the wet bulb, the greater possibility, okay? So for number 15, as the difference between the dew point temperature and the air temperature increases, the likelihood of precipitation is going to decrease. Number 16, just another one. You got 16 degrees Celsius and the wet bulb temperature of 9 degrees. You just got to find the difference and then plug it into your chart, which ends up being 16 is going to be 50 degrees. And remember, using the second chart because you're looking for relative humidity. All right, 17, what is the approximate dew point temperature if the dry bulb? So you have 22, and then you have 12. So 22 degrees Celsius, you got 12 degrees Celsius. Difference is 10. You plug that in to your dew point chart, which is the top one, and you get 3 degrees Celsius. If the amount of water vapor in the air increases, then the dew point temperature of the air will also increase. Okay, that comes right out of the reading before this. 19, the air temperature is 10 degrees Celsius. Which dew point temperature would result in the highest probability of precipitation? So remember, you're trying to get the closest one, all right? So it's telling you it's 10 degrees Celsius. You want dew point to be as close as possible to 10 degrees Celsius. The only one is going to be 8 degrees Celsius, which is going to be choice 1. And then the last one for number 20, according to the Earth Science Reference Table, as altitude within the troposphere increases, the amount of water vapor generally. So remember, we live in the troposphere, okay? That's the bottom layer. That's the first layer of the atmosphere as you're going from the ground up, okay? So as you go up in altitude, pressure goes down, okay? But it also goes down in water vapor. So number 20 is going to be choice 1. And where you can actually see that is if you go to page 14 on your reference table, it actually gives you a graph like this. That's called water vapor. All right, it's the third graph on the top. Now, as it goes up, it's showing you that most of our water vapor, basically all of it, is only in the troposphere. And that is why all of our storms, all of our weather only happens in the first layer of the atmosphere, okay? So that's basically it for the day. I just wanted to go over this. Now, for the weekend that we're going to go over on Monday, we have page 319 to 329. It's a little bit of reading, and then it's questions 1 to 20, okay? I understand that some of you guys don't have the textbook, so I'm going to take a couple of pictures and then submit it on Google Classroom, all right? And again, this is only for 8th grade, all right? 7th grade doesn't have to worry about this. Does anyone have any questions or concerns? All right, I'll see you guys later.